how to create sparse matrix using linked list. I'll discuss this algorithm. Okay, create procedure. In previous class, we have discussed about this algorithm. In now, I will discuss today's class. I will discuss how to create the linked list sparse matrix. Okay, before that, let me recap for 10 minutes what we have discussed in previous class. Please don't hesitate to listen. Please listen. You all know all these things, right? These are basics. You all know all these things, but again I will discuss. In previous class I have discussed about working of for loop and working of nested loops, right? Again I will discuss for 10 minutes. Please listen. Already you know it, but please listen. See, working of for loop. See, for loop, first statement is initialization, second statement is condition, third statement is increment statement. Again I am repeating. See, for I equal to 0, this is initialization. This part is, first part is initialization, second part is condition, third part is increment statement. Okay, now let us see. 1 second. Okay. Yes, okay. See, let us see working of for loop. See, without understanding the working of for loop, you cannot understand the algorithm, right? See, first, first control comes to initialization statement. I equal to 0 will be executed. Now, I value is 0. Next, control goes to condition check. See here, initialization statement will be executed only once. Students, is my voice is clear? Student, is my voice is clear? Or it is very low? Please let me know. Message in chat box. Students, is my voice is clear? Okay. Now see here, remember that always initialization statement execute only once. Control comes to initialization statement only once. I equal to 0 will be executed only once. Later, control goes to condition check. Second step, control goes to condition check. After condition check, if condition is true, control goes to, see, condition is true, control goes to inside for loop, body of the for loop, which contains some statements. Third step. Okay, now these statements will be executed. After executing these statements, okay, after executing these statements, control goes to increment statement. I plus plus, fourth step, control goes to increment statement. After I will be incremented, that means I becomes 1. Okay, previously I equal to 0, I plus plus means adding plus 1 to value. What is value of I? 0. 0 plus 1, nothing but now I equal to 1. After this, again repeat the same procedure. Control goes to condition check. Fifth step, control goes to condition check. If condition is true, again control comes inside for loop statements. Again these statements will be executed. Again control goes to I plus plus. Now I will be incremented. Previously I equal to 1, right? I plus plus means I plus 1 plus 1, that equal to 2. Now I becomes 2. Again condition check. Okay, again condition check. If again condition is true, again control comes to inside for loop. The statements which are present inside for loop will be executed. Again control goes to I plus plus. Okay, after incrementing I plus plus, now I becomes 3, right? Again control goes to condition check. If condition is false, control comes out of the for loop. Statements will not be executed. Okay, is it clear, students? Students, are you able to understand? Is the concept is clear? Did you understand working of for loop? Students, please reply. Did you understand what I am saying? Shall I continue? Only one member, always only one member is responding. What about remaining members? Sleeping or what? Only 2 members are there in the class. See, you need to respond. If you are not responding, I'm not able to understand whether you are understanding my what I'm explaining or not. Okay, okay. Now let us see working of nested for loops. Without understanding this, you cannot understand the algorithm. That's why again I am explaining. In previous class I have explained. 1 second. Yes, just wait. Just wait for 2 minutes. Let us see working of nested for loops. Nested for loops. Working of nested for loops. See, you know all these things. Please don't hesitate to listen. Listen. Already you know all these things. Again, listen. Please listen. Okay. For in see nested for loop means 1 second. I equal just I will write and then I will explain one. For I equal to 0, I less than m, I plus plus for j equal to 0, j less than n, j plus plus some statements. Okay. Okay. Now let us see. See, nested for loops means placing for loop inside another for loop. Okay, outer for loop and inner for loop. See in this way. This is outer for loop. Outer loop. This is inner loop. Now let us see inner loop. Now see here, control comes to I equal to 0. Now I value is 0. See, listen carefully. I value is 0. Okay, next control goes to condition check. If this condition is true, control comes inside the for loop. Okay, inside the for loop, what is the statement present inside the for loop? Again, there is for loop, right? Now control comes to j equal to 0. Now when I equal to 0, j equal to 0. Okay, next control goes to condition check j less than n. This is condition check. Control goes to condition check. When this condition is true, control comes inside the inner for loop and it executes all the statements. All these statements will be executed. After that, again control goes to j plus plus. See here, I equal to 0 only. Here for loop will be inner for loop. See inner for loop will be continuously executed until condition is false. When the j is less than n is condition. See inner for loop, I'm talking about inner for loop. When the condition j less than n is false, at that time only control comes to I plus plus. Okay, please try to understand. Next, see here. See, I equal to 0, j equal to 0. That means what you are doing, I equal to 0, j equal to 0 means, see, I equal to 0, 1 second. I equal to 0, 1 second, what is this? See, I equal to 0, j equal this one. I equal to 0, j equal to 0. You are accessing the element. Okay, m of mat of I, j. That means mat of 0, 0. You are accessing 0 first element. Okay, I hope you understood. Okay, next let us see. Okay, now see here. What is this control set? Okay, see here. Now what is happening? Condition is true. Inner for loop. I'm talking about inner for loop. See, inner for loop will be continuously will be executed until condition is false. When j is less than is false, then only control goes to I plus plus outer for loop. Okay, now j equal to 0. Again, what is happening? Again, condition check j less than n. I'm talking about inner for loop. It is true. Again, control comes to inside statements of inner for loop will be executed. Again, control goes to j plus plus. Now see, j plus plus, j equal to j plus plus means 0 plus 1 you need to add. Previously j equal to 0, 0 plus 1 that equal to 1. Now I equal to 0 only. Okay, previously j equal to 0 you have accessed 0 first element. Okay, now j equal to 1. J equal to 1 means you are going to access which element? I 0 only. I 0 only. See which element? I 0 only. Your j, now j becomes 1. Okay, that means which element you are going to access? 1 mat of mat of I, J. I is mat of I is 0 only, right? Now J became 1. Mat of 0, 1. Mat is nothing but this matrix name, array name. Okay. Mat of 0, 1 means you are accessing, see here, 0th index, 0th row index, see, 0th row and first column. What is the element? 0th row and first column element 1. You are accessing 1. Okay. I hope you understood. Now what is happening? Let us see. 1 second. Please try to understand. Okay. Now what is happening? Let us see. Now, see again inner for loop will be executed continuously. Okay. Now J became 1, right? Again control goes to J plus plus. Now J equal to 2. 1 plus 1. 1 plus 1 that is equal to 2. Okay. See. Now again condition check. 2 is less than 2. False, right? See, 2 is less than 2. 2 by 2 matrix, right? Okay, 2 by 2 matrix. 2 less than 2. It is false. 1 second. See here. This is false. I'm talking about inner for loop. See, inner for loop condition. Now J becomes 2. 2 less than 2. False, right? When this condition is false, now control goes to I plus plus. Okay, outer for loop. See, outer for loop. I plus plus. Now I became 1 second. See, now I became I equal to 1. Again control goes to inner for loop. See, again control goes to inner for loop. J equal to 0 will be executed. Okay. When I equal to 1, J equal to 0. Again condition check. Inner for loop. I'm talking about inner for loop. Now control is at inner for loop. J equal to 0 will be executed. After that, control goes to condition check. If the condition is true, the statements present inside inner for loop will be executed. After that, again control goes to J plus plus. I'm talking about inner for loop. Now J plus plus means, see, I equal to 1, right? J equal to 0. Let us see what is we are accessing. I equal to 1, J equal to 0. Let us see what we are accessing. See, I equal to 1, right? Now I equal to 1. I equal to 1. See, now I is pointing to 1. J is 0 only. J is 0 only. That means you are accessing first row, 0th element. What is first row? This is first row. 0th element means this one, right? First row. So, first row, 0th column. First row, 0th column. This one you are accessing. Next element. You have access to first 0th row, 0 element, and 0th row, first element you have accessed. Next, I became 1. You are accessing. When I became 1, J is 0. You are accessing first row and this one, first row and 0th column element, nothing but 0 you are accessing. I hope you are you're able to understand. Okay. Okay. Now see here. Now see here. Okay. See here. Now, after condition check, again J will be incremented. I equal to 1, J equal to 0. Again J will be incremented. Incrementing J plus plus. I'm talking about inner for loop. See, inner for loop will be continuously will be executed until the condition is false. Okay, now J plus plus means you need to add plus 1 to previous value. What is the previous value? 0. 0 plus 1. Now J is 1. I is 1. I is 1 and now J is 1. Let us see what you are going to access, which element. I is 1 and J is 1. See, you are accessing like this. Mat of I, J. Nothing but mat of I is 1, right? Now J became 1, right? Mat of 1, 1. Which one? This one. First row. Okay. Row index. First row index, first row index and first column. This one and this one. This one. Okay. Which element? First row, this one. First row, first column element. Which element? This one, right? First row, this one. First row, first column element means this one. Now you are accessing 0. I hope you understood. In this way, you are going to access. First, you will access 0. Next, you will access 1. Next, again, you will access 0. And next, again, you will access 0. In this way, for loop will be executed. In this way, you are going to access each and everything. I hope you understood. Is it clear, students? Please trace it out. You will understand. Is it clear, students? Is it clear? Topic is clear. Students, you need to respond. Shall I explain it again? Or okay? See, always only one member is responding. What about remaining members? Is it okay? Is it topic is clear for you? Okay. Now, see, I will explain this. Why mat of ij is not equal to 0? What is happening here? If mat of ij is not equal to 0, what you are calling? Create. Why this? Why you are calling create? I will explain. See here. Wait, I will explain. 0, 1, 0, 0. Okay. This is mat. Array name is 2D array name is mat. Zeroth row, first row, zeroth column, first column. Okay. Now let us see what is happening. See, first you are accessing first element 0 you are accessing. When you are accessing 0, you are comparing whether it is not equal to 0 or not. See, if, one second, if mat of 0, 0 not equal to 0. See, mat of first initially you are accessing this element, right? 0th row, for 0th column element. What is that? 0 not equal to 0. True or false? 0 not equal to 0. False. See, what is happening means when you are accessing non-zero element, you need to create. Here, 0 is non-zero element, not non-zero element. See here, 0 not equal to 0. It is not true, false. When this is false, nothing. You are doing nothing. Okay, next. Okay, nothing. See, inside for loop, there is a create state, create function call. Okay, there is a create function call. See, 0 not equal to 0. When this condition is false, you are not, control is not going inside for loop. Okay, control is not going. Okay, create function is not calling. Okay, we are not calling create function. Now, next you are going to access which element? You are going to access, one second. Just wait. Okay. Okay, just wait. See here. Next, one second. See, next element 0 you have accessed. Next element is this, right? You are going to access 1. Okay. See here. Mat of 0. Mat of 0. 1 element. What is the 0, 1 element? See here. 0th row. 0th row. 0th row. First column element. What is 0th row? First column element? 1, right? Now, 1 not equal to. See here. 1 not equal to 0. This is true. See, what you are doing means in matrix you are accessing each and every element. While you are accessing each and every element, you are comparing whether it is not equal to 0. If the element which you have accessed is not equal to 0, then only you are creating the linked list. Then only you are creating the linked list. If the element which you have accessed is 0, you are not at all creating the linked list. Okay, remember that. That's why here we have put this condition. You are going to access each and every element. When you are accessing each and every element, if the element which you have accessed is 0, you are not creating a linked list. Okay. When you are accessing a non-zero element other than 0, see here, you have accessed 1, right? When the element is 1, you are creating the linked list. You are calling create function. Okay, see, 1 not equal to 0. This is true. When this condition is true, control goes inside the if statement. What is present inside the if statement? Create function. Create function, what it is doing? It is creating the linked list. Let us see it. I hope you understood. Let us see it. See, this is what we have explained in previous class. Okay, when this condition is true, when you are, see, when this condition will become true, see, when this condition will become true, when this condition will become true, when you are accessing non-zero element. If you are accessing zero element means you are doing nothing. Okay, control, this condition will become false and control will not go inside the for loop. Create function is not calling. When you are calling create function, when if condition is true only, when if this if condition will become true, when you are accessing non-zero element only, this if condition becomes true. Okay, if there is non-zero element only, you need to create linked list. Let us see how to create linked list. Okay, let us see. See, before that, again I will explain some basic. Please listen. Okay, you know all these things, but please listen again, once again. Now, see here, linked list. You know that for sparse matrix linked list, node contains four fields. Node contains four fields. First field is row index. Next field is column index. Next field is value, non-zero value. One second. What is this? Just wait. Okay. Just wait one second. Val, not value. Val. Okay. First field is row. Second field is call. Nothing but index. Next field is val. Next is next. It is a pointer which contains address of next. Now, see here. For example, this node name is temp. This node name is temp. Here, I'm explaining only basics. Okay, please listen once again. Now, I want to access row field. Now, I want to access row field. How to access? Anyone? Students, please answer my question. Okay. Please answer my question. How to access a row field? The node name is temp. I want answers from you. Students, I want answers from you. I want to access a row field of temp node. How to access it? No one is answering my question. Students, please answer my question. I want to access a row field. Roll number 6, roll number 8, 10. Remaining members, please answer. Yes, very good. 36, Mahesh Babu. Yes, temp of row. Temp arrow mark row. Tejvamsi, okay. Temp of row. Only 2 or 3 members. What about remaining members? Okay. Only 2 or 3 members only responding. See here. Already you know all these things. Once again, see. See, now I want to access row field. What is the node name temp? You need to use node name. What is the node name temp? Temp arrow mark. Why are you using arrow mark? Because you are here you are using pointers. Here temp is a pointer which contains address of this node. Which contains address of this node. Okay. Temp of row. Temp of row. If you want to access column, temp of call. If you want to access next field, what is next field name? Val. Temp of val. If you want to access next field, temp of temp arrow mark next. Okay. I hope you understood. These are basics. Okay. Roll number 10. Okay. Shravanti. Okay. Okay. I hope you understood. Now, here is my question, students. How to represent this node in memory? How to represent this node in memory? I want answers from you. Students, please answer. I want to, one second. How to represent a node in memory? What you need to declare first? Students, I want answers from you. How to represent node in memory? The basic question. Without this, how can you implement the algorithms? How to represent this node in memory? What you need to declare first? No one is answering my question. No one knows. Already in previous class I have discussed. Students, How to represent this node in memory? What you need to declare? Yes, using structures. Tejavamsi, very good. Pranita, structure. Haripriya, struct, very good. Rajalakshmi, okay, very good. Yes, you need to declare, you need to use structures. Okay, declare the structure. See how to declare. See here. Struct, you need to use struct keyword. Struct. This is structure name. I'm using node. Your wish. Structure name can be your wish. Struct keyword. Next structure name. Next open curly brace. Now see how many fields are there. Row, call, val. See, row contains integer only. Call contains some integer only. Val contains some integer only, right? So data type int row. Field name int call, because the row field contains integers only, right? Column field contains integers only, right? Next int val, non-zero value, integer only, right? Next, what is the next field? What is the next field? See, next field points to the next node. That means next field is a pointer which contains address of next node. So data type is struct node only, because it is pointing to another node, right? What is the type? Struct node. Struct node, struct space, give struct space node, next space star next, because next is a pointer. Remember that pointers only contains addresses. Semi close the structure, close the structure. Next you need to give semicolon. One second, just wait 1 second. Yes, see here, close the structure. After that, see here, see, row, call, val, next, all these are structure members. The variable row, the variable call, the variable val, and the variable pointer variable next. All these are declared inside the structure. That means these are called structure members. See, now if you want to access a row, call, val, next, you cannot access directly. You have to access only using structure variable. Here, see, structure variable, see, head, star, head, pointer. What is structure variable here? Head. Head is a structure variable. Star head. Head is nothing but it is a pointer which contains address of first node. Initially, head equal to null. You need to initialize like this. Head equal to null initially. Now, if you want to access row, head of call, head of val. Okay. See, in program, if you are accessing directly like this, row, directly call, you will get error, because if you want to access structure members, you need to access the structure members only using structure variable head. Here you have declared structure variable as head. Pointer variable, right? Pointer variable means you need to access like head arrow mark, head arrow mark, row, head arrow mark, call, head arrow mark, val, head arrow mark. Next, okay, these are the basics. I hope you understood. Now let us see. 1 second. Okay. Now let us see. Now see here, I will explain how to create. This is very simple. Okay. If you know how to create single linked list, same procedure. Same procedure. Now let us see what is. See, initially head equal to null. Head equal to null. Okay. Now this is a matrix 0, 0. 1 second. 1 second. Okay. Wait. 0, 1, 0, 0. Now what you're doing is indexes are 0, 1, row column index 0, 1. Now let us see. Let us see what you're doing. See here. See, initially head equal to null. Okay. See, when this 1 second, when this procedure head, when this is called, when you're accessing non-zero element, when you are accessing non-zero element only, control comes to this what is this control comes to function call. What is that function call? Create. Now create function will be called. See, remember, when you are accessing non-zero element only, it is not equal to 0 when this is true only. Okay, when this condition will become true? When you are accessing non-zero element. For example, you are accessing 1. You are accessing 1. Now, what is the row index of 1? 0. See here, this one. What is row index of 1? 0. What is row index of 1? 0. Now, j equal to what is column index? This one. See here. See I'm marking. What is that? What is column index of 1? 1. J equal to 1. What is value? Non-zero value you are accessing, value equal to 1. Okay, you are accessing 1, right? When you are accessing non-zero value only, this create function is called. Okay, now see here. Head is null. Head is null. 1 second. Okay, see here. Head is null. X value is 1. I value row index is 0. J value column index is 1. Okay, I hope you understood. 1 second, I'm erasing this. Okay, see here. Okay, now see. Now wait. Now see. See, initially head is null. X value or X is nothing but non-zero value. And what is non-zero value is 1, right? Non-zero value row index is 0 and non-zero value 1 column index is 1. Now I equal to 0, j equal to 1. Now what is happening? Control for 1 second. Okay. Now first step will be executed. First, what you are doing? You are creating a node using malloc. Creating a node. This is a row field. Call val next. Okay. See what you are doing. Temp equal to struct node star malloc size of struct node. Now memory will be allocated. What is the name of this node? Temp, because you have given temp equal to, right? No, so node name is temp. Node is created using malloc. You need to remember this statement. Okay, in C language, this is the statement to allocate memory. Now, what you are doing? See, temp of row equal to I. What is I value? See here, I equal to 0, right? I equal to 0, j equal to 1. Non-zero value, val equal to x equal to 1. See, I equal to 0. 0 will be inserted. Row index of non-zero. Non-zero value you are accessing is 1. Now, the value 1 row index is 0. 0 you are inserting in row field. Temp of row equal to I. I is nothing but row index of non-zero value 1. So, 0 you are inserting in row. Next, see the next one. J. What is J value? 1. Okay. J value is nothing but column index of non-zero value. I is nothing but uh, row index of non-zero value. Okay. Now, see what is happening. 1 second. Let us see. See. J, what is J here? J1. 1 will be inserted in temp of call equal to J means you are inserting J value into temp of call. See here. 1. Okay. Next. This statement will be executed. What you are doing? Temp of val equal to x. What is x value? Non-zero value. Okay, non-zero value 1. Okay, non-zero value 1. 1 will be inserted in temp of val field. Okay, now what you are doing? Next, see, this statement will be executed. Temp of next equal to null. Null you are inserting in temp next. Null you are inserting in temp next. So now temp next field will be null. Okay, I hope you understood. Now first node is created. Okay, first node is created. Next, just wait. Okay, now next, see here, what is the next statement? If head equal to null, this one, 1 second, again I'm drawing. This is temp, right? Temp. This is 0, this is 1, 1, null. This is row field, call field, value, next field. Okay, let us see. Now, next statement. What is the next statement? If head equal to null. See, initially head is null, right? Initially head null only. So, when you are creating first node, then only step 4 will be executed. When you are creating second node, step 4 will become false. Okay, see here. If head equal to null, head is null, right? Null equal to null, true. Null is equal to null, true. When this is true, these two statements will be executed. Head equal to temp, you are assigning temp address to head. See, head equal to this statement. I'm talking about this statement. Head equal to, wait, 1 second. See, this one. I'm talking about this one. Head equal to temp. You are assigning temp address to head. Now head points to temp node. See, head equal to temp. You are assigning temp address to head. See here, temp address to head. Now head points to temp. Okay, see, head points to, now head is pointing to temp node only. What is the node name? Head and temp. Now see here, set last equal to head. Set last equal to head. Again, what you are doing, you are assigning, see, you are assigning head address to last. Again, last points to this node only. Okay, temp pointing to first node only, head is pointing to first node only. I hope you understood. See, otherwise statement, else part will not be executed. When this else part will be executed, I will explain, right? Wait. Now, see, when this else part will be executed, when you want to create another node. See, when you want to create another node, for example, you have created another node. This node name is head, right? Previously head, temp, and last. Okay. Now see here. You have created another node. For example, think that there is another non-zero element. See here. Think that there is another non-zero element like this. There is another non-zero element, something like that. So when you are accessing value 1, here you are calling function, you are calling this function create. Node is created, right? Node is created. Again, you are accessing 0. If you are accessing non-zero value, means condition will becomes false. Create function will not be called. Okay, when create function will be called, when you are accessing non-zero value only. Now you are accessing again 1. Okay, second row, see, 0th. Okay, see here. Now when you are accessing non-zero value, again create function will be called. Okay, now you again create function will be called. Again, see here, again create function will be called. Now again you are creating another node called temp. So this node name is, okay, now see, this node name is temp. Okay, this node name is temp. Again, what you are doing, you are inserting I value, j value, x value, and null. Okay, think that you have inserted. Next what will be executed? If head equal to null, see here, head is pointing to first node. Head contains address of first node. It is not null. See, it is not null. Head contains address of first node, some address. Okay, this condition becomes false. So otherwise statement will be executed. What is the statements present in otherwise? See, last of next equal to temp. What you are doing? Last of next equal to temp. That means last next. What you are assigning? Temp address. What is the last? See, what is the last here? Last is pointing to first node, right? Last next. See here, last next equal to temp. You are assigning address of temp to last next. See this one, last next equal to temp. That means last next points to temp. You are assigning address of temp to last next. Last is nothing but first node name. Last next field. See, why you are taking last means you should not move head. Head always must point to first node address only. You should not move head at all. That's why you are taking some other variable just like last, and you are using this last. You should not move head always should point to first node only. Okay, that's why you're not at all taking head, you are taking some another variable. Using that variable you are assigning addresses. Last of next equal to temp. Last next field, what is last? Last is for pointing to first node, right? Last next equal to temp means last next field points to temp node. Okay, now see here, next statement. What is the next statement? What is the next statement? See, please try to understand. This is very easy. Next, 1 second. Next statement, this one. This one will be executed. Last equal to temp. Now you are assigning address of temp to last. Okay. Now last point to temp node. Okay. Now last points to what is this? 1 second. What is this? Okay. See here. Now see here, last equal to temp. After assigning last of next equal to temp, last next field points to second node. Okay, last next field points to second node. After that, what you are doing means last equal to, see this statement, last equal to temp, you are assigning temp address to last. Now last points to second node. Last is not point to first node because you are assigning address of temp to last. Now last is pointing to next node. I hope you understood. Again see here, again see 1 second. See again, if you are creating another node, again if you are creating another node, for example you are accessing another non-zero element, again you are creating another node. What is the node name? Temp. What is the node name? Temp. You are creating another node, so node name is temp. Node name is temp. Now see here, again what is happening? Again what is happening? You need to insert some values. Temp of row equal to I, temp of call equal to j, temp of val equal to x. Nothing but x is a non-zero value. Non-zero value. And I is a row index of non-zero value. And j is a column index of non-zero value. After inserting, again fourth statement, see, head equal to null. Head contains some first node address. It is not equal to null, right? This condition becomes false. When this condition becomes false, control comes to else part. What is else part? See, head last next equal to temp. Now what is temp here? Third node. See here, see this one, third node. Now last next, what is last? Last is pointing to second node only, right? Last next, this one, last next equal to temp. That means last next pointing to temp node. Last next equal to temp means you are assigning address of temp to last next. That means last next contains address of temp. That means last next is pointing to temp node, third node. After that, last equal to temp. Now last becomes temp. Now last points to temp node. Okay. In this way, you are creating linked list. Is it clear, students? Please try to understand. This is very easy. Please trace it out. After this class, after the class, please trace it out. When you have time, please trace the algorithm. It will be very easy, students. It is not at all tough. Don't by heart. If you are by hearting means, you won't remember at all. If you understand means only you can remember this. You can implement these algorithms. Is it clear, students? Students, what I am explaining is clear for you? What I am explaining is clear for you? Are you able to understand or not? It is very easy if you understand. Please trace it out. Take a piece of paper and please trace it out. Don't trace in air, okay? Please put your pen on paper and trace it out. You will understand. It's very easy. Linked list is very easy if you understand. See, don't by heart it. You can't understand. If if you are by hearting, you can't remember at all. These are not problems. Okay. Only one member is responded. Only 18 is responded. What about remaining members? Are you able to understand what I am explaining? Are you able to understand? Okay, roll number 8. Okay. Haripriya, 35. Only 3 or 4. Okay, okay. Okay, roll number 10. Okay. I hope you understood. So, there is time 49 only. Okay, there is 10 minutes. Okay, just wait. Okay, students, thank you. I will explain. Next, polynomial expression. Sparse matrix linked list creation is completed. I request all the students to trace it out. If you trace it out only, you will understand. Don't by heart the linked list. Please trace it out. Okay. Okay, just wait for 1 minute. Okay, students, sparse matrix completed. Now let us see polynomial expression. You know what is meant by polynomial expression, right? See, polynomial expression which contains more than two terms. Okay, polynomial expression is nothing but it is an expression which contains more than two terms, which is made up of coefficients and exponent. You know this one. See, example 4x cube 6x plus 3. Here, what is coefficient? What are coefficients? 4, 6, 3 are coefficients, right? What are exponents? See, x cube, x power 1, x power 0. What are exponents? 3, 1, 0. I hope you understood. You know all these things, right? Expressions, polynomial expressions will be in the form of ax square plus bx plus c. Okay, here a, b, c are called coefficients and exponents are nothing but x square. X square. Okay, 2 is an exponent. Here, coming to bx, x power 1 is an exponent. Coming to c, x power 0 is nothing but 1, right? 0. Once again, see here, polynomial expressions, applications of linked list. You need to implement this polynomial expression in linked list. If you want to implement, first you need to know what is polynomial, right? A polynomial will be in this form ax square plus bx plus. Here what you need to understand is what are coefficients, what are exponents. You need to understand here what are coefficients. A, b, c are coefficients. Next, what are exponents? See, x power square, x square, 2 is a coefficient. Next, x power 1, sorry. 2 is an exponent. 2 is an exponent. A, B, C are coefficients. 2 is an exponent. Next, coming to bx, x power 1, right? X power 1. Okay, 1 is an exponent. Next, coming to c, x power 0, right? X power 0 is nothing but 1, right? That means now here exponent is 0. Okay, you need to know this. What are coefficients, what are exponents? Is it clear, students? Students, is it clear? What are exponents, what are coefficients? Are you able to understand? Already you know all these things. Now let us see. If you want to implement these polynomial expressions, there are two ways. First, using arrays. Next, using linked list. Okay, using arrays and using linked list. In your syllabus they have asked using linked list only, so I will explain only linked list. Once again, see the polynomial, how the polynomial expressions will be like ax square plus bx plus c. Here what you need to identify is what are coefficients, what are exponents. Here see the example, 4, 6, 3 are coefficients. Coming to here, coming to exponents, x cube 3, x power 1. Next, x power 0, 0, 3, 1, 0 are exponents. See, x cube 3 is an exponent. X power 1 is an exponent. Coming to 3, there is no, this is a constant, that means x power 0, right? So 0, take powers of x term, powers. Exponents are nothing but powers. 3, 1, 0. Using this only you need to see, using these coefficient and exponents only you need to identify what are coefficients, what are exponents. Using these only you are going to create the linked list. Now let us see how to represent this polynomial expression in linked list. Let us see it. See, each node in polynomial expression contains three fields: coefficient field, exponent field, and next, which is a pointer which contains address of next node. Okay, see here. Each node in polynomial expression contains three fields. Node representation. First field is coefficient. That means you need to insert the coefficient. Next, exponent, exp, exponent. You need to insert exponent. See here, you need to, this is a coefficient. Next, this is exponent. Next, this is next, which is a pointer which contains address of next node. Okay. Now let us see. Let us see. See if you want to implement, sorry, one second. Okay, one second. See, if you want to represent this node in memory, how to represent it? First, you need to declare a structure, and then you need to use malloc function to allocate memory. Once again, I'm repeating. If you want to represent this node in memory, how to represent this node in memory? First, you need to declare a structure. After declaring structure, you need to use malloc function to allocate memory for that node. See here, struct space node. Here, structure name is node. Next, see how many fields are there? 3 fields, right? How many fields are there? 3 fields. First field is coefficient. Coefficient is nothing but integer value only, right? See here. Coefficient 4, 6, 3. These are integers. See the exponents 3, 1, 0, x power 3, x power 1, x power 0. These are also integers, right? That's why here you need to declare like this: int space coefficient, coeff, field name. Next field, what is the next field? Exponent, exp. It is also integer, right? Int space exp. Okay, int space exp. Next, what is the next field? Next field is nothing but it is a next, which is a pointer which contains address of next node. Remember that only pointers contains address. Only pointers contains address. Okay. See here. See, how can you declare a pointer? Before variable name, if you specify star symbol, it is nothing but pointer. See here, what is the type of next? Next is pointing to next node only, right? So that's why type is struct node. Struct node space star next. Struct node space star next. Okay. Close the flower brace. Now, see, if you want to access coeff coefficient, exp and next field, you cannot access directly. You need to declare a structure variable. Here, coeff, exp and next are called structure members. Okay, if you want to access these members, here you need to declare a structure variable. Here I have declared, what is the structure variable I have declared? See here, p. Using this p only, you are going to access coefficient, exponent. Next, how to access it? See, how to access it? One second. See, p of coefficient using structure variable. What is structure variable? P here. Structure variable is p. P is a pointer, right? P is a pointer. If you are using pointer, means you need to use arrow symbol. P of, p arrow mark coefficient. Next, p arrow mark exp. P arrow mark next. In this way, you are going to access. Okay. Initially, p equal to null. Okay. Initially, p equal to now. Now, let us see linked list. Now, this is the, see here. See the example. One second. See the example. 4x cube plus 6x plus 3. What are coefficients? Let us allocate a node for 4x cube. See here, first node. See how many terms are there? 1, 2, 3. That means three nodes. You need to draw 3 nodes. Okay. First node 4x cube. 4x cube. 4 is a coefficient, right? Insert 4 here. Next, what is the exponent? 4x cube. 3, right? So insert 3. In next field, see, coming to 6x. 6x. Okay, see here, next field contains address of next node. Okay. Next, see here, 6x. Create a node using malloc function. Create a node. Okay, now you need to insert 6 because 6 is a coefficient, right? Insert in coefficient field 6. After, what is exponent? 6x power 1, right? X power exponent. You need to insert, what is exponent of 6x? What is exponent of x? 1, right? So insert 1. Okay. Yes, this node is completed. What is the next term? Only 3, right? 3. Now see here, what is the coefficient here? 3 only. Insert 3. Next exponent. Exponent is nothing but x power 0, right? X power 0 is nothing but 1, right? Okay, I hope you understood. So 0. Okay, in this way you are going to create the linked list. I will explain the algorithm later. In next class, I will explain the algorithm. At that time, how to insert these nodes you can understand. Okay. Once again, see here 4x cube plus 6x plus 3. This polynomial expression can be represented using linked list in this way. Okay, there are three terms. That means there will be three nodes, and each node you need to insert coefficient and exponent of the term 4x cube in this way. Next 6x, second node, see the second node, in this way you need to insert. Next 3 is nothing but 3x power 0. Okay, so coefficient is 3, exponent is 0. Okay, in next class I will explain how to create this linked list algorithm. I will explain it, and also I will explain what addition operation and multiplication operation of polynomial linked list. Okay, students. Okay, time is up. Okay, thank you. If there are any doubts, please respond. You can ask me at any time. I'll respond to you. Okay, thank you, students.